Space Friend. I should have done this way earlier, but I think I'm finally going to get into the ship systems, figure some basic things out about it, like the name of the ship, and then I'm probably going to change it. I found this LCD lying around and thought that'd be a cool way to print some stuff instead of just using the serial monitor all the time, so let's figure out how it works. There's multiple types of LCDs, but my favorite is the I2C. It's also probably the simplest to use, so that's what we're going to use today. I2C stands for Inter-Integrated Circuit. It's a communication protocol for electronics. Communication protocols are like communication between humans. You need to be able to speak the same language in order to understand each other. The three most common communication protocols are the I2C, as well as Serial Peripheral Interface, and Universal Asynchronous Receiver Transmitter Driven Communication. God, that's hard to remember. Since we're using an I2C LCD today, that's the only one we're going to talk about for now, but I'll have other videos to discuss the other two in more detail. More commonly known communication protocols are USB, Bluetooth, Wi-Fi, or Ethernet. These are all faster than I2C, but I2C uses less system resources and hardware. It's great for low-speed communication devices like sensors, microcontrollers, analog to digital or digital to analog controllers, and input-output interfaces. A big advantage of the I2C protocol is that it only uses two wires for communication, a serial data line or SDA and a serial clock line or SCL. SDA transfers the data and SCL carries the clock signal. A clock signal is an electrical signal that oscillates between logical high and logical low. It acts like a metronome to synchronize the timing of components within a digital system. The protocol operates in two modes, master and slave. A side note, master and slave are terms that have been used for decades in computing, but that's largely been unchanged due to a lack of diversity within the tech community. Over the last few years, they've been slowly changing the terminology. Python and GitHub now use phrases like main and slave under the reasoning that the association between the two words is what makes it more inherently negative. I'm going to be using the terms either main and slave or primary and secondary throughout this video, but I just wanted to give that explanation because if you look into these kind of things, you'll see the phrase master and slave a lot. So just know I'm talking about the same things, I'm just using more updated terminology. The main device is something like the Arduino or a PC. The slave is a peripheral device controlled by the main device. I2Cs allow for multi-device communication, so the main device can communicate between several slave devices. For this reason, each device has a unique address. This lets the primary device select which secondary device it wants to send the data to. The main sends every slave device the address of which slave it wants to communicate to. The slave then compares that address to its own address. If it matches, it sends a low ACK bit back to the main. Another side note, I don't know if you say ACK or ACK. If you know, please tell me in the comments. If it doesn't match, the slave's SDA line stays high and it does nothing. The main device transmits data in messages that are broken down into frames. I2C is a serial communication protocol, so the data is transferred bit by bit along a single wire, which is the SDA line. It begins with a start condition. Here, the SDA line switches from high voltage to low voltage before the SCL line switches from high to low. Next is the address frame, which is the unique address of the secondary device. Next is a read-write bit. This is a single bit that specifies if the main is sending or requesting data. Sending data to the slave is at a low voltage level and requesting data is at a high voltage level. Next is the ACK bit, which is an acknowledge or no acknowledge. If the address or data frame was received successfully, the secondary device sends back an ACK bit to the main. The acknowledge or no acknowledge is followed by the actual data being transferred, and each data frame is followed by another acknowledge or no acknowledge bit. Finally, the message ends with a stop condition. The SDA line switches from low voltage to high voltage after the SCL line switches from low to high. Both the SDA and SCL lines are pulled high. I'll link a video that explains what I mean by pulled high in case you need that first. Data transfers can only be initiated when the I2C bus is idle. The bus is considered idle when both the SDA and SCL lines are high after a stop condition. Because of this, a pull-up resistor is required so that both lines are high. We'll need two things to get started using this LCD, the write library and the I2C address. Other LCDs use a library called Liquid Crystal, but this one requires a library called Liquid Crystal I2C. I'll put a link in the description to where you can download that library. We can get the I2C's address using an I2C scanner, which I'll also include a link to. Just scroll down to the sketch and copy and paste it into the Arduino IDE. Once you've ran the sketch, open the serial monitor and note the I2C's address. Now, LCDs don't typically come in any basic starter kits, but it's great to buy just as a single component anyways. You can integrate them into so many different projects that they're still really useful to have. We've got all kinds of different ways to display information on them, so let's go over a few different examples. First off, let's get into our ship system though and figure out the original name of this ship. Oh, yikes. You know what? I'm sure the previous owners named it ironically, and they were actually really bad people. I'm going to rename my ship the R.Yakshi, which translates to Demon of the Night Winds, because it makes me sound cool and maybe no one will mess with me if I show up on their radar. Granted, they would also have to understand a fictional video game language from Sol System in the 21st century, but whatever. We need the LCD and 4 male to female jumper wires. Super simple. Connect ground to ground, VCC to 5V, SDA to A4, and SCL to A5. First, we need to include the liquid crystal I2C library and the wire library. A library is just a set of functions that we can add to the program. We have to always specify that we're including it so that the code inside of it will be available to us. The liquid crystal library is of course for the LCD itself, and the wire library is what lets you communicate to I2C devices. Okay, so this first liquid crystal I2C LCD, this is creating an LCD object which is referencing our physical LCD. Then we need to give it 3 pieces of information. This first one is the I2C address. Mine is the 0x27. Yours can be something different. Put your specific address that you got when we ran the I2C scanner earlier. The 16 and the 2 are referencing how many characters that the screen can display. 16 is 16 characters, 2 is 2 lines, so you can have a total of 32 between both lines. If your LCD is a different size, just change those values. Init. This is this particular library's name for a function that initializes the timer counter. Some libraries also use begin for this. Since unfortunately it's not always standardized, you may need to look into the documentation for the library that you've downloaded if init doesn't work for you. Backlight turns on the backlight. Set cursor specifies where you want the cursor to start at. A cursor is the position of the letter to start displaying the text at. On a 16:2 LCD, the first argument can be 0 to 15 and the second can be 0 to 1. Print just prints out the text. We're going to use it to celebrate our new ship tech. We're doing 2 cool things with this code. LCD.home places the text in the upper left-hand corner of the screen, and adding in this initial print statement for new ship tech in the setup and then the X's in the loop makes the loop text print on top of the setup text print. Cool. LCD.clear clears out the text that's on the screen and positions the cursor in the upper left-hand corner. If you use this with delay and print together, you can make the text blink. Scroll display left or scroll display right scrolls the text either left or right. It moves at 40 spaces, and if you have more than 40 spaces, then it goes to the next line starting at 41. Cursor creates a visible cursor, and no cursor turns off the cursor. Using them together in the loop like this will make the cursor blink on and off. Display just turns on the text with the cursors that you printed to the screen. The difference in no display and clear is that display turns off the screen without clearing the text from memory. Auto scroll. This moves the text from right to left at increments for however many characters you have in the string, which again goes up to 40 characters. If you had a 2-character screen, it would go 2 spaces at a time. Me putting in a long sentence here makes it basically unreadable because it's going over 27 characters at a time. Right to left prints the text in reverse. In order for the entire text to be visible, you have to use the set cursor. Otherwise, the default's going to be in the 0 to 1 position, and you'll only be able to see the first character of your text. You can change the values that are in set cursor and then just move it around on the screen. Coquette. This. Win. Custom characters are awesome, but this is a lengthy code that I did not write myself, so I'm going to link to this in the description so that both for credit and also so that you can just copy and paste it. We're using the byte data type here instead of int or float like we've been doing a lot of, because the variable that we're storing here only requires 1 byte of memory. The brackets after C1 signify an array. Arrays can store multiple values at once. The 8 means that we're going to have 8 values within the array. The values within the array are user-defined graphics. I'm going to include a link that goes over how you can create your own custom graphics. LCD create character. Up to 8 characters of 5x8 pixels are supported with this function, and they're numbered 0 to 7. The appearance of the characters is specified by an array of 8 bytes, 1 for each row. The order of the loop is specifying 8 characters at a time. The syntax is number data, where num is the character between 0 to 7 to create, and data is the character's pixel data. And using set cursor moves each character to the next row placement on the screen. Now that we know so many ways to display text on an LCD, I've got so many ideas for how to use them in the future. Can't wait.